Thank you, Ed, and thanks, Amy, and everyone involved in organizing the conference. It's been excellent so far, and it's an honor to be here. I'm going to talk with you about Chef, which we're running at UST Libraries to deploy servers and deploy infrastructure. So that means configuration management, automating application deployments, and in particular, why this technology might be of interest to the library community. And we're going to have a live demo. I love live demos. You never know what's going to happen. They can be great. They can really be bad. It adds some tension and excitement in the room, particularly for me. So I am looking forward to that. We'll see how it goes. What we're going to do in the live demo is take a bare Ubuntu 12.04 server with nothing on it but the OS and turn it into a fully functioning Islandora repository server with Drupal, Islandora, Fedora repository, everything you need to make that work. Should take about 659 seconds. That's the average of about 5 runs I did earlier this week. We'll see how it goes. I've been working in libraries since 5 days after my 14th birthday. And back then, when we needed circulation statistics, shortly after I started working, the plan was devised to put a blue dot on the spine of every book when it came back after being returned from a user. Then the blue dots start falling off, and they'd end up on your hands when you shelved the books, which is what my job was. Then you put a piece of tape over the blue dot to secure it to the spine. So over time, over the couple of years that this project ran, the most popular books' spines ended up covered in blue dots, and then they migrated onto the covers. But at the time, as a teenager, I thought this was sort of ridiculous. But looking back on it, it seems like an excellent example of hacker community in libraries, even back then, because the librarians identified a very clear need. They needed circulation statistics. They didn't have any. So they came up with their own method, blue dots on the spine. They got what they wanted. When the solution ran into problems, such as the dots falling off, they put tape over them. It was, in fact, kind of a beautiful solution to a problem. It went away after about 2 or 3 years. Whether they got another system in place to replace it, I'm not sure, but it kind of introduced me to the kind of makeshift and do-it-yourself attitude you often get in libraries, and one that I appreciate to this day. Currently, I'm a network administrator and network systems administrator, network manager at UST Libraries. My interest is really in building IT infrastructure so that we can kind of get IT out of the way so that librarians and developers can get their work out to the users. And part of this is the reason I got interested in Chef, building web and database applications quickly. I've been interested the last few years in, there's a movement in the web to build sites to run as fast as possible and with as much automation as possible. This comes from some work from O'Reilly and Velocity Conference down in California every June. If any of you have ever been there or know of it, it's an outstanding conference in web serving IT, and I'd highly recommend it. This is our We Are Big slide. UST Libraries, the 3rd library in North America in the ARL Investment Index, about 17 million items. For about 20 years, we've had a very heavy focus on electronic resources, and we do quite a bit of local storage of those resources, locally building applications and interfaces for users. We have a major partnership with the Ontario Council of University Libraries for the Scholars Portal project, which is a consortium of about 22 university libraries to do consortial licensing and serving of electronic resources to the university communities around the province. So out of UST Library, we host and house the Scholars Portal IT infrastructure and staff. In our 7th floor data center, which is the building we just saw, it's about 100 feet by 60 feet, I think. We house about 200 Intel-based physical machines, quite a bit of this is our We Are Proud of Our Cabling slide, so as neat as possible. Quite a bit of networking infrastructure, and about 500 terabytes of storage mostly for electronic journals, PDF books, and so forth. This is a SAN from Pillar Data Systems, and various individual servers house about 100 terabytes locally as well. But the main focus here that I want to talk about is it's not really about the hardware, and in fact, in many ways, I'm hoping the hardware is kind of moving out of the way. I'm much more interested in building fast and reliable and highly available services for users, and for creating collaborative environments between programmers, developers, and designers on one end, systems people in the middle, and librarians as well, so that we can build these things together without a lot of the conflict and stress that you sometimes get in IT environments. That's something I want to talk a bit about later in the presentation. The technology environment for this will be open source tools. We run all of our new machines with either Ubuntu or Red Hat Linux. We use Linux KVM for virtualization. Entirely, in this talk, web applications, so Apache, MySQL, PHP, Tomcat. And all this leads to Chef, which is the tool we've been using for about 18 months now to deploy these applications. This is the definition from the OpsCode website. OpsCode is the company that built Chef and has been running it for about 3.5 years. And I'm focusing initially on the systems integration part and the cloud part at the end. Chef does configuration management, and there's a few buzzwords, buzz phrases around the industry lately. Infrastructure as code has been around for a few years, infrastructure automation. The key concept here is that if you're running 10, 20, or 100 servers or more, that you have every piece of your infrastructure in some element of code, source code, separate from the server itself, so that you're able to rebuild machines very quickly, and your infrastructure, that is everything you need to run your systems, is independent of the physical hardware it's actually running on. So a Chef environment ensures that your servers are running the applications and versions of those applications that you define, and it ensures that they are configured the way you define and that they don't stray from that configuration. And if they do, Chef server puts them back the way they should be. It does this, Chef server, it's a traditional client-server architecture. The Chef server piece is a Ruby application, uses Rails front end with Myrtle, CouchDB for data store. JSON is the format it uses to exchange data between clients and the Chef server and administrative clients. Solr for searching the data about your environment, and RabbitMQ for doing messaging back and forth. The key point to remember about Chef server is that it stores information about your environment. Chef client, which runs on the nodes controlled by Chef server, Chef clients are called nodes. For this talk, we'll call them nodes. And data about nodes is referred to as attributes. Nodes in a Chef environment have hundreds of attributes, and you will use attributes to define elements of how the client behaves. Chef client runs at definable intervals, usually 15 minutes every half hour. And when it runs, it asks the server, Chef server, what it should do, how it should be configured, what other nodes in the environment it needs to know about, and then it applies that configuration to itself, either doing all of the work, which we'll see in a moment, or doing none of it if it already is in that state. In other words, it keeps state consistent over time until you tell it not to. So I'm going to move to the live demo, or at least kick off the live demo, making Island Aura in 659 seconds. It's gone down by 1, I think. This will take a base Ubuntu server and install the applications you see here. These all come out of code and recipes and definitions I've put on my Chef server, and the Chef client will talk to it. So bear with me while I switch to a PuTTY session, which is here. So this is my Chef client, island2.library.utron.ca. It's a base Ubuntu 12.04 server. It has no software on it other than the operating system. There's no MySQL client. Java, if I can type, is not installed. There's about 370 packages here. The Chef server, I've installed the Chef client on this machine, so it can already talk to my Chef server. The Chef server already knows what this client should do because I've placed those definitions on the Chef server, but they've never actually interacted to the stage of actually doing the configuration. They've just defined the authentication, the ability to talk to each other. So if I run Chef client, first thing it does is it connects to the Chef server and downloads all of the cookbooks, which are the terminology for a set of tasks it has to run, from Chef server, stores them all locally, and after it gets them, it will compile them all. It's all Ruby, so it compiles it into executable code and then starts running it. So as you can see, it's getting things, getting Perl, that's fairly legible, Perl, PHP, Nginx, Tomcat, more Nginx, Amazon Web Services. At this point, the client doesn't know what it's supposed to do. So when it starts getting cookbooks, it gets everything it needs, including dependencies for things that it might not actually execute. Over time, it then weeds that stuff out. And shortly, I believe, so it's done downloading, now it's compiling, and it will start actually doing the tasks now. And the first thing it does is do an apt-get update to update its repositories to make sure it has the latest versions of everything that exists. Now it's actually doing its work, installing packages one after another. So I'll go back to the presentation. We'll come back to that in a bit. So some of what you just seen are these pieces here. Recipes are the key piece of actually executing tasks in a Chef environment. Recipes will perform a single task or many tasks. The prime use of them is to install an application and install configuration for that application. So you might put an Apache server on and then put all your Apache config files in place. This sample I have here is for installing MySQL client packages, and it basically creates a Ruby word array of 2 package names and iterates through it, installing them. You notice here that this code is very generic. It doesn't actually say anything about how an operating system would do the work. It just says action install. That's because the Chef recipes are designed to run on any of several operating systems: Red Hat, Ubuntu, Mac OS, Arch Linux, CentOS, Debian. So the recipes themselves are generic enough that you can apply them to a number of environments. Attributes are the data about nodes that get manipulated when the recipe runs. This is a typical set of attributes from MySQL Server or Fedora repository server, where it would say define MySQL port, MySQL data directory. These are things that have a very large set of normal defaults that you would use, but you can then define exceptions to these defaults and apply them to specific nodes as desired. So 99% of your MySQL servers would not run on port 3306, but if you had a need for 3307, you would merely define that for a specific node and give it that definition. That way your templates, the next slide, don't need to change, but your data comes in and executes at runtime. So in this case, the template for a my.cnf file would define a MySQL port, taking the value assigned to that node. That can vary across nodes and across runs. Another thing templates can do, templates are typically used for config files. Apache config is an excellent use for template virtual host configurations. Templates can execute Ruby code. In this case, the bottom one for Apache, I've set up an attribute for SSL only is yes. So you have a web server that you force to be always HTTPS, and you never want to answer any HTTP. Your generic Apache site definition file will have in it this code, which says if SS only is yes, set the rewrite engine to on. If the condition is HTTPS not on, rewrite it to HTTPS. This will force any machine to get responses with HTTPS and lets you put generic code in all of your Apache configuration files to allow for HTTPS if you assign it outside of the server definition itself. One really nice thing about using templates this way is that every one of your Apache servers or MySQL servers, all their config files are separate from the machines they run on. They all end up on the Chef server, and they can all exist in version control, because it's typically you would put a cookbook in version control. Every time you change it, increment the versions. So you have a historical record of every configuration in your architecture. If you're running 20 Apache servers, 50 Apache servers, it's extremely useful to have this record of your history. Cookbooks are the conglomeration of the last 3 things I described that take all those files, recipes, attributes, templates, and combine them into one discrete unit, which is a file system directory and is a typical unit for version control. Roles are taking those elements and turning them into an application. So a role might have multiple recipes it would run and specific attributes. You see at the bottom here, this would be a role for standard Apache server, and at the bottom it says SSL only no. You might say, have another role called Apache server SSL, in which SSL only is yes. Then you can just reassign those roles to servers as you need and have their configurations come alive automatically. Roles can also contain other roles, and the thing that's executing now in the background, our role for Islandora server, is doing each of these tasks in sequence: Apache, MySQL, PHP, or LAMP server role, Drupal, and Tomcat, Solar, Jatoka, hope I'm saying that right, Fedora server and Islandora 12, which itself does a variety of tasks. The last piece of this stuff is data bags. Data bags are information about the infrastructure that exists outside of any particular node. So you would typically use data bags for creating things like user accounts, MySQL user names and passwords. This is my data bag for me and all my servers. And one of the beautiful things here is that, say you have 10, 20, 100 servers, you only need to create a recipe for creating a user account Stewart G on all your machines with this data, apply it to the 10, 20, 50 servers, and it will be present next time Chef Client runs. So I know I have an identical account on all my Linux machines. I know what the password is because there's a hash here. Feel free to reverse engineer it if you wish. Other user accounts can be done this way. You can disable user accounts by wiping out the hash, however you want to do it. It's extremely versatile. If you're running a lot of Linux servers, your user account management problems essentially disappear if you're running a system like this. Let's see how the live demo is doing. I'm curious. Okay, it is still running. It's done, right now it's installing the libdbxml package required for Fedora, I think needs that. Now it's doing Fedora repository itself. So it's getting the jar file for Fedora installer, puts it under the Tomcat directory, restarts Tomcat, and proceeds from there. So I'll come back to it in a moment. See, it's just restarted Tomcat. Okay, so live demo. Chef Community, one of the great advantages of a product like this, it is a commercial product. The company makes their money off of hosting Chef installations and doing IT consulting and services, but there's a very active community in the Chef open source world. There's about 400 cookbooks that exist on their site. It's a great place to go if you're interested about cutting edge applications in the Linux world. If you have something you want to try out, something where perhaps the install is a bit of an issue, you're curious about how people are building applications, especially applications that talk to other applications, it's a great place to go to see what's available. If there's a cookbook for something, chances are it will kind of work. You'll always have to do your own work to get it running, but that's in fact normal. So, Ruby, how many people are here Ruby programmers? Do Ruby? A couple. So initially I was a bit worried about Ruby. Most sysadmins have done a fair bit of scripting. I'd done Perl and Bash and so forth, but Ruby had me a bit worried. This fellow, Adam Jacob, is the co-founder of OpsCode. At Velocity in 2010, he had the great expression, I thought, sysadmins are polyglots. And I would say also system librarians are. If you do any coding, you've done one language, you can easily learn another. It hasn't been a problem at all. So if Ruby is a concern, if you've done any coding, not an issue. Why is Chef useful to us? Well, if you're running many servers, it's extremely useful, assuming you have a common environment for them. A great feature I find is to be able to never do anything twice. It's actually maybe 3 times. You would do it once to understand how it works, once to code the recipe to make it function. After that, you should be able to allow your Chef server to apply all definitions and application installations you need. The easily recover infrastructure, I think, is a really interesting point. If all of your definitions of how your applications are configured and what applications you need to run, and the application itself, because you can use Chef to deploy application code, if all of that exists separate from the physical servers it runs on, it means that the only thing left is your data, which itself is restorable through backup or whatever. But to actually bring your infrastructure alive, you no longer are dependent on the physical hardware you're currently running it on. If you know what your applications, if it's all defined in a Chef server, and there's other products such as Puppet or CF Engine that do this as well, you no longer have that. When I started in IT, and you still see it a lot now, this one big server sitting in a corner somewhere that no one's touched in years. It's absolutely critical. No one remembers at all how it was configured and what's on it, and no one will touch it. But it's critical to your organization. That used to be very common. It's still quite common. But this system, assuming you do gradual migration away from that kind of stuff, means that you never end up in that scenario again. Because we have a number of servers running now that if they go down, I will rebuild them in 10 minutes. And it's extremely, it gives, as a system administrator, it gives you great confidence in what you're doing. And also, obviously also it leads towards the cloud, which is something I'll talk about in a bit. The next two useful points, anyone recognize these from the Perl world? Tim Tody and Tim Tody bicarbonate. Tim Tody is, there is more than one way to do it. Ruby, coming from that background, you can do things any number of ways. In Chef, you can write the code 50 different ways to do the same thing. It's kind of charming. Tim Tody bicarbonate, however, says there is more than one way to do it, but sometimes consistency is not a bad thing either. And that applies in all sorts of areas of life, and coding as well. And here in particular, I think Chef sticks to these values, and they're very charming. I particularly like the last point. You can wait for your boss to come to you with a project and say, sure, I'll do that right away, which is a great experience. How many of you have had the experience of going to IT and getting yes for an answer? So it does happen, of course, and I'm not, the most common response is no, or we'll get to it, and I'll talk about that, a bit about that in a second as well. But the advantage of this, of course, you end up with, was it Jennings paradox that the fellow referred to yesterday, where something becomes commoditized and then it becomes more common. So if you can build your servers in 10 minutes, you have to build more servers, in fact. But the reality is that you are confident in your ability to do things, and that itself is a great bonus. Let's see how the, okay, so the demo is done, Chef client completed. It took 642 seconds, so we were 20 seconds fast. So it's run once. I'll run it again, and it will actually do nothing this time except check everything it has to do and confirm that there's nothing that needs to happen. But while that's running, we should now, if I open a web browser, have available an Islandora server. I should have shown you this before, but hey, okay. So this is the machine we just built. It didn't exist 15 minutes ago. It's Drupal with Islandora behind it. I can remember the login. Potato Man. Feel free to log into this if you want, Islandora admin and Potato Man. So it, if we go to administer and Drupal 6. This is all the latest versions of what you expect in Drupal 6. Under modules, you'll see that the Islandora modules are all in, oops, image cache. Islandora modules are all installed and enabled. The one thing that I haven't yet completely figured out the scripting for here is that although the modules all exist and are present, I need to save the configuration once through the interface in order to access the modules through the Islandora interfaces for them. How many of you are running Islandora here or have run it? Yeah, of course. Okay, so if now that I've enabled it, I can go to site administer, yeah, and I will have here now under site configurations, the Islandora pieces here. So this shows you that Islandora is installed. It knows about the local Fedora repository installation, all the bits and pieces you need. It talks to the repository and so forth. So this is a functioning Islandora installation now, built by Chef, and the Chef client has just run in 51 seconds because it took that long to figure out I, in fact, have nothing to do. But if I were to go into this server and wipe out my Apache config file, restart the Chef client, it would see, oh, file's gone, put it back and restart Apache. So it's a very clean product that way for managing your systems. So usefulness. An example of how we use it at UST Libraries is how we run our main homepage, which is a Drupal site itself. Because you can code everything, it really gives you the advantage to then get deeper into the applications. If you spend less time configuring every one server to make it perfect, you can configure 12 servers to make them perfect, because you're repeating a lot of the tasks over and over again. So in this case, we run an HA proxy load balancer with keepalivedaemon as holding the DNS name for onesearch.library.utron.ca. It proxies the HTTP requests out to 4 Drupal servers with caching in front of them. The MySQL queries go out to a memcached installation, also as keepalivedaemon in case one goes down, and that talks back to 2 MySQL servers. The great thing about this setup is that the Drupal hosts, the Apache and PSP boxes, are fully configured by Chef, and I can add new hosts very quickly when application increases in the fall or spring. So sites are now using this and have been for a few years to do all auto-scaling of their sites. If you're running on Amazon or somewhere where resources cost you a lot of money, they'll set triggers throughout the day and cut down to 10 servers overnight and go up to 50 during the day and cut down again to 10 again. They use tools like Chef to do this kind of work. And we're doing that at UST Libraries, not with automatic triggers, but manually adding machines through Chef, taking 10 to 15 minutes each. During the busy months of the year, taking them away in the summer and applying those resources to other tasks. This is the OneSearch site. We're also using Chef in this case for our library discovery layer, which is fronting an Endeca index or Endeca indexes. This is 7 Tomcat and Java servers sitting behind HA proxy, configured with all configured with Chef, talking to an Endeca server, also configured with Chef. And this is a new Islandora site we just built. One of our digital collections librarians, Andrew McAlorum, built this UFT heritage site through Islandora, and it's been going with Chef from the beginning. So it's a great opportunity for us to try a complex application like Islandora with many pieces to install and configure to run in Chef in production. So nothing's perfect. It's not the simplest thing to learn how to use. You need some support from your IT department for it. There's great potential for big failure. If you can build 20 machines in an hour, you can destroy that many in an hour. In fact, destroy them quicker than that. If you upload your cookbooks with syntax errors in them and the thing won't restart Apache because it puts in some bad code into your config files, all your web servers will go down. So you want to have some kind of development environment, some kind of way to test things before you roll them out. We've been bitten a few times by this. It's also a bit bleeding edge. They do a lot of releases and are very aggressive about the release schedule. Things sometimes don't work always right. But one thing to point out is this is in its infancy. These tools have only existed for a few years. They're driven by the cloud. And as a system administrator, I'm confident that in 5 to 10 years, we will not recognize the kind of work we're doing. How many of you here would call yourselves systems administrators? Yeah, so a good number. I would pay attention to this kind of thing. If you're able to run it, try running it or something similar like Puppet, because the automated services that will be provided to do this kind of work and will already exist but will be made easier and easier. The development of local clouds and private clouds to run inside your organizations as opposed to going to Amazon, which should get around some of the political institutional issues around cloud services. They will really change the work we're doing. And I think this is definitely something to try. The company is quite successful, so acquisition potential is an issue. They recently released a Windows client, which had rumors about Microsoft purchasing, kind of hovering, but they're heavily geared towards the open source world. So for the IT department, how is this of interest? One thing in particular for me, it's important, is trying to find a way for the IT department to not be a roadblock for development. And we're lucky at UFT Library because the IT department is part of the library. And so we are dedicated to the library's goals, and our aims align nicely. So we're able to do something like Chef because we see the value to it. But the scenario of going to your system administrators or going to your IT department and getting no for an answer is very common, I think. And any way, any tool, any skill, any ability that leads to decreasing this roadblock, making it perhaps not exist, it's an institutional issue in a lot of organizations, I think would be extremely valuable. For system administrators, I think we as a profession really need to get away from the grumpy stereotype and the hostile, antisocial, no, system administrator who says, years ago, a colleague said to me, just tell them, what was the phrase? Just tell them you'll do it as time allows. So what does that mean, right? I think there's a great value in getting out of that stereotype, because I think we'll be bulldozed over by other technologies if we don't. And if any of you are system administrators, if you haven't done that already, do it. Stop that kind of mentality and start to stop seeing yourself and your organization as a roadblock to what your users actually want to do. Users, on the other hand, I think if you're frustrated with your IT departments, which you maybe have a great relationship, I'm sure it's all over the board, change has to happen in some way, and perhaps that change maybe needs to start with a conversation, just taking someone for coffee, having a chat, trying to find some common ground that leads to cooperation. Institutionally, it might be hard to do, but I would strongly recommend whatever steps you can take to lead to a better cooperative relationship with IT will lead to better results. It might be challenging at first, there might be historical things to get over, but it's very important, I think, for our community. Chef is and will be a way for us to deploy our servers in the cloud, or a cloud, whatever cloud that might be, whatever kind of virtualized environment that might be. I'm hoping it's one we run locally and provide services to our users like the NCSU speaker just referred to. It is the path that will be used for this, and that will be what is happening in the next 3 to 4 years in our communities. Another area of interest for the library community, I think, will be encouraging the use of applications. The library community produces lots of great and interesting software. We've seen a bunch of it at the conference. I would be very interested in working with anyone here who has presented on software or has software on GitHub, anything that needs installations, to work on creating chef recipes to make it functional. Not functional, installable, easily installable. I think we've had many cases, Allendore is one for us, where we knew this thing was out there. The actual task of getting it to run was a big roadblock to actually moving forward with it. There's this thing, we know it's complex. If there are recipes and cookbooks and defined methods already existing, I think we'll encourage adaptation, adopting applications, decreasing time to usage, and getting you to the point where you can actually show something to users as opposed to, yeah, we're still working on it. So anyone interested in working on a project like this with me, let me know afterward. To that end, I've built a GitHub site for the recipes we just built Allendore with. There's 5 individual recipes here because they all serve a different function. Fedora 1 builds a Fedora repository server. Gsearch puts in the Fedora generic search application. Allendore does all the Allendore modules and pieces. Solr is a great one which runs on itself independently to install Solr. I haven't yet done the readmes and descriptive text for these, but that'll be within a week. And if any of you are interested, please bug me about that, because it really needs to happen. I think it'd be great to create some kind of community around these kind of tools in the library context. This, of course, isn't just me. It's the whole team I'm working with at UST Library to make this happen. The names are here, and we have a great working relationship with all these folks, and we're very happy to be able to present here to you. So thank you very much. And questions?
Time for 1 or 2 questions, and there's 4 or 5 hands up, so we won't be able to take them all, unfortunately, but I will take a few.
I actually have a question from a fellow who's not here,
Sure.
Bill Ingram, and he asked, anyone at Access YUL want to ask him how he automates the provisioning of the base Ubuntu box or Chef client, e.g. with Vagrant or VirtualBox or something?
Yeah, we're not using Vagrant or virtual boxes. We would use Vagrant if it doesn't support KVM virtualization right now, which is the virtualization we're running.
Yeah.
I don't believe it does. So what we do is we have templates for different versions of Ubuntu, and we have scripts that copy those and give them IPs. So that part is a manual process, and it's on our slate to get that automated ASAP, but
Okay, thank you.
it's manual right now. Yeah.
Question. Chef looks great. Looks like the easy button for staples, reminds me of. But how does it handle upgrading? Like how would you guys, it's easier to set up when it's a blank machine and
Yeah.
you can get it up and running, but when you have data there and you need to do the upgrade, what
Yeah.
are the lessons learned?
Well, that's a great question. One of the things that this does is that you get less invested in the individual machines because, again, your application, all of your code for creating your application exists outside the machine. So in that array of 12 or 4 Drupal servers I showed, they're running Ubuntu 11.04 right now. It's my goal to upgrade them to 12.10 in December with a Drupal upgrade. So I'll build one test server for that. The cookbooks and recipes will all be basically the same. And you can roll it online one by one and replace the 4. So the question about upgrading is your servers often don't live long enough that you need to upgrade them, right? The lifespan is sometimes you never even reboot them, and if you're in a busy environment. Of course, we're used to thinking of applications that stay static for years or are upgraded gradually. Application code typically comes out of version control or through putting WAR files on an HTTP server and pulling them into Tomcat that way. So we try to have base OS and application, and then application code as a separate piece, and putting that onto new versions of operating systems and new versions of hardware is relatively easy because all of those definitions exist outside of the machine you have running initially. Yeah. So does that, yeah. So.
Okay, we have a question for more. Was there a question back there? Did Nick have it over here? Okay, a question over here.
How do you deal with dependencies? For example, you have one server running on Fedora 12 or something, and your next project is Drupal 7, needs Drupal 7, but your configuration is based on Drupal 6. How do you take care of those kind of?
Yeah. So there's a couple of ways to do that, but basically the cookbooks can be for an application such as Apache, and you assume it will install the default current version of Apache that the OS grabs. But for something like Fedora, where it's a fair bit of manual work and you're tied to Java versions and Drupal versions, and you see it as all as one piece that you need to build, I would build a cookbook for Fedora for Islandora 12.2, and that piece would have the recipe in it for Fedora 3.42 that it needs, and a recipe for Drupal 6.2.2. Yeah. So then the procedure when Islandora is available on Drupal 7, I'm assuming they'll be upgrading the Fedora version for that release to a newer one. That will mean writing the cookbook pieces to build a Fedora to 3.5, whichever it might be. Same with the Solar versions are the same way. So within a cookbook, you can have individual recipes for doing versions of an application, or you can write a cookbook that works at application version level. It kind of is a preference thing because in some cases, if it means you're grabbing a gzip file, unzipping it, putting it in a directory, having Tomcat see it, it's a fair bit of manual step, and you might want to just write a separate task for each of those things and publish them separately. So one point about this is that it helps you understand the environment better. So you understand these dependencies and relationships more, and you're building, as a system administrator, I've had to put more thought into how I'm actually building applications when I'm using Chef than I used to. Because if you're automating it, you have to know every time it's going to work. You don't want the thing to run and just suddenly break something that you'd never seen before. So, yeah.
Oh, that's all we have time for. So thank you very, very much.
Thank you. Thank you.